Hey there, Internet. Thanks for joining me for a very, very special episode. Why is it so special, you ask? Well, because I've officially made this many videos.
Yeah, it's party time. Oh, I don't know why my voice is so high.
Wait, hold it.
What?
You've been doing this for over 5 years, and you've definitely made more than 100 videos.
Aha, I never said that number was 100.
Now, did I? That's right, we're gonna talk about math today. Spoiler alert, this is actually my 256th video. However, as I was thinking through what I wanted to do for today, I happened upon the fact in my brain that I've been planning for a very, very long time to do a video about alternate base mathematical systems, which may very well be a phrase that sounds like gobbledygook to 99% of you. However, it is something that I find fascinating, and it just so happens that 256 in base 10 equates to 100 in base 16, except it's not actually 100, it's just represented by this set of digits, so there's no words for it, there's just symbols. But we'll get to that later. So, Johnny, most of you are probably scratching your heads and asking, what on earth is an alternate base mathematical system? Well, you've probably heard that we here in English speaking everywhere use a base 10 mathematical system. In fact, I think most languages around the world use base 10 because the Arabic numeral system has been widely adopted in a lot of different countries, not just ones that speak English. Turns out there's something about it that just sort of latches onto our human brains. I don't know. I didn't do any research for this. This is all based on stuff I learned in like middle school. I'm blathering. Base 10. What is it? What does it mean? To learn that, we gotta turn to the math cam. That's right, we have a 2-camera setup today. So in normal day-to-day life, you might write a number that looks something like this. 347. Yes, I crossed my sevens. It's the vastly superior way to go. And because we've learned numbers like this, we automatically interpret it. It's 347. But let's stop and think about what that actually means. Way back in elementary school, you learned about things called place values. You had your ones place, you had your tens place, and you had your hundreds place, as well as a lot of other places off in this direction. In fact, infinitely many places off in that direction. So when you look at this number, what you're really saying is that I have 7 ones, which equals 7. I have 4 tens, which equals 40. And I have 3 100s, which equals 300. You add these all together, and you get 347. But to understand alternate base mathematics, we really need to get one level deeper below the surface and ask ourselves, what are these numbers? Why is this the ones, the tens, and the hundreds? The answer comes in exponents, or powers, whatever you like to call them. Because we're using a base 10 system, we want to interpret each of these places as an exponent of 10. 10 is really easy, that's just 10 to the first power. 100, also similarly easy, 10 squared, or 10 to the second power. And something that's kind of confusing, and despite being a math lover, it's never quite latched into my brain, is that anything to the 0th power, or 10 to the 0th power, is ones. So you can look at this and see that we have 10 to the 0th, 10 to the first, 10 to the second. If we had thousands over here, it would be 10 to the third, 10 to the fourth for 10,000th, and so on and so forth. Decimal places work exactly the same way. You could have 10 to the minus 1, which is 0.1, 10 to the minus 2, 0.01, etc., etc., etc. Every place value in our mathematical system is defined in value by 10 to a power, increasing by integers and decreasing by integers to the left and right of the decimal point, respectively. Are you following me so far? Because it's about to get weird. So we've just learned how exactly a base 10 system operates. The trick now is that we can replace that 10 with any number you could ever possibly want. You could use a base 2127 math system, although counting would be deeply impractical. You can have a base 2 math system. That's what binary is. It's what computers run on. I'll probably touch on that a little bit more in a second. You can have a base 8 system. It's called octal. Or what we are most interested in today, you can have a base 16 math system called hexadecimal. Let's figure this sucker out. Rather than starting with a number that we know the value of, 347, and working our way down to the place values, we're going to start by defining our place values. So just like powers of 10, we're going to start with 16 to the 0th. That looks like 16 to the 6th. Hold on, I can't write. We're going to start with 16 to the 0th, which, as I just said, anything to the 0th is 1. Our next will be 16 to the first power, which is just 16. Then we'll do 16 to the second power, which is 256. Yeah, these numbers get really big really fast. 16 to the third power. Let me do a quick math thing over here because I didn't plan this out beforehand. 15, 0, 2, 5, 6, I can't read, 6, 9, 4,096. Okay, so this is 4,096. We're not going to go up that high because I don't feel like dealing with it. But those are our place values. I'm also not going to do decimal points because decimals in alt-base math are difficult. So if we wanted to convert a base 10 number, like let's say 127 in base 10 into a number xxx in base 16, that's how you write bases, by the way, you just put a little subscript next to the number, we would have to stop and do some long division. Yay! So we look at 127 and we see how many times does 256 go into that? None. So there's no digit in this place. How many times does 16 go into it? So it's going to be 7. Another quick math thing over here, that's 42. 7, 112. 127 minus 112 to get the remainder is only 15. So we're going to have 15 in this column, which leads us to an interesting difficulty. I can't write 15 here because that takes 2 digits. It's not acceptable. You actually need more than 0 through 9 to write in hexadecimal. In this case, convention has become to use A through F as the next 6 digits. So 15 in base 10 is written as an F in hexadecimal. Thus, 127 in base 10 becomes 7F in base 16. It doesn't look like a number, I know, but it is. Moving on, we wanted to figure out why is 256 written as this in base 16. Well, you probably caught on with what we were doing last time, but we're going to start again with 16 to the 0th, 16 to the 1st, 16 to the 2nd, that's 1, 16, 256, and we want to figure out what does 100 in base 16, or those symbols, represent. So the number we have is 1, 0, 0. We're going to have 0 ones, that's 0. We're going to have 0 16s, that's 0. And we're going to have 1 256, i.e. 256 plus 0 plus 0 equals 256 in base 10 out of 100 in base 16. Ta-da! So, I've made 256 videos in base 10, I've made this many videos in base 16, and you now, hopefully, understand how alternate base math works. I love it. I've always found it fascinating. No one is probably still watching at this point. I want to touch for just a second on binary because I said I might earlier. I alluded to the fact that that's a base 2 math system, and it works well in computers because it only requires 2 digits to write. It requires a 1 and a 0 that can be an on and an off state within a circuit. It's genius. Just like base 16 requires more digits, base 2 requires fewer. So we're going to start by writing out our powers: 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, etc. Converts into 1, 2, 4, 8, 16, yada, 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 yada. So if I had a number like 14 in base 10 and wanted to write it into base 2, I would stop and say, okay, in 14, there is 0 16s, there's 1 8, which leaves 6 left over, which means there's 1 4, 1 2, and 0 1s. So 14 in base 10 converts into 0 1 1 1 0 in base 2. Very conveniently can be written with zeros and ones, interpreted by a computer, and then make things like calculators work. That's what I wanted to talk about today. Happy 100th video, I guess. It has perpetually bothered me that there's no way to speak alternate base numbers. Get on it, mathematicians. Maybe there is. Maybe I should have looked it up. Let me know down in the comment section if you have any questions about this whole concept of alternate base math. I think it's a really good way to stretch your brain mathematically and get it thinking more abstractly about numbers as a concept rather than as a written thing on a piece of paper. And clearly, I love talking about it, so, I'll talk about it some more. Or alternatively, let me know what's your favorite really dumb/obscure math concept. If you have one, probably don't. See you next week. Deuces.